All right, so this is just a warm-up to trigonometric equations. We're not going to do anything major here. However, we sort of have to do some training to train our brain to see things sometimes. So, for each of the equations below, solve for the basic trigonometric ratio, sine theta, cosine theta, and tangent theta. Now, note that sine theta squared is equal to sine squared theta, right? So since we're squaring the ratio, we can write it as sine squared theta, and nothing happens to the angle. So really, we're squaring the ratio. When this is written, or this is written, when we write cos squared theta, really we mean we take the ratio, the cosine ratio of theta, and then we square the ratio. Anyways, what would I like to do here? The long-term plan, anyways, is to get you really good to identify the trigonometric ratios. Allow me to start. I am going to try to isolate sine theta. And I'm going to use two methods. First is going to be, in my first half, I'm going to be using what is known as substitution. Now, substitution is a really neat trick in which something seems complex or unfamiliar to you, you just make a substitution. So for instance, let x equal sine theta. Now, I need to write this, let x equal to sine theta, and I can make a substitution. So 6 plus 9x is equal to 0. I know how to isolate x when I'm in this circumstance, and it's easy peasy, so I'm just going to say, I'm going to subtract 6 from both sides, and then I'm going to divide both sides by 9, and maybe I'm going to simplify that. So therefore, we're not solving for x. Remember that x is sine theta. So sine theta is equal to negative 2 over 3. Wow, this seems like a really big beast here. So if you want, you can factor that off the top of your head. Not many people can look at that and do that. So instead, I'm going to say, let x equal tan theta here. Now the trick is, what am I doing is I'm trying to take something unfamiliar and change it into something that I'm really familiar with. There. Oh my. That is definitely more familiar to me. So now I could factor this using the product sum rule. Two numbers that multiply to positive 2 but add to negative 3. That would be positive 2 and positive 1. And if I'm solving for x, I would say x is equal to negative 2, or x is equal to, that should be x, is equal to negative 1. But really, I have to remember, I'm not solving for x, I'm actually solving for tan. So I have to say, well, or tan theta is equal to negative 2, or tan theta is equal to negative 1. So remember, I'm not really doing trigonometry. I am just trying to solve for the trigonometric ratios. Later on, we will be solving for the angle theta. That's sort of beyond our scope for today. Last but not least, here, I'm going to take this. I want to play this substitution game. Oh, wow. So I can read your mind. And you're thinking, I'm just going to divide both sides by tan. No, you're not. Please stop. You cannot, whenever you have a variable, you cannot simply divide out that variable. So maybe I'm just going to say, let x equal tan theta, let y equal to sine theta. So what do I have? tan sine, I would have xy is equal to 3x. So I can't divide both sides by x here, right? And if I did, that would leave y is equal to 3, and that would all be nice, but that's going to be incomplete. What we have to use is the zero product property. So I'm going to factor out an x out of both terms, and this ends up being x. All right, I think I may have lost my train of thought there before that interruption. What I have is here x times y minus 3 is equal to 0. Using the zero product property, I can equate both factors, x is equal to 0, or y minus 3 is equal to 0. So this is solved for x. I'm going to solve for y. Y is equal to 3. So in other words, this equation is solved when x is equal to 0 or y is equal to 3. Now I have to go back to my original definitions. In other words, where tan theta is equal to 0 or sine theta, that was y, right? Sine theta is equal to 3. Just for fun, when is sine theta equal to 3? Never. All right, I'm going to press pause. I'm going to absolutely erase everything here, and we'll start from scratch. But we will not use substitution. All right, so I'm going to solve for sine theta, and I've highlighted this in green, just to sort of help me along in my process and how I think about it. If I wanted to isolate, so this is 6 plus 9 times sine theta is equal to 0. If I want to isolate sine theta, what would be my first step? Well, it's the same exact step as algebra, what you've been learning all along. So, ooh, that was terrible. You would really subtract 6 from both sides. So now we have 9 sine theta divided by, 9 sine theta is equal to negative 6. Now I'm going to divide both sides by 9. There. So now I have sine theta is equal to negative 6 over 9, and I could simply reduce that fraction into negative 2 over 3. There, I've isolated the tan or the sine ratio. Let me move on to the next example. I got mail. So I'm just going to highlight tan ratio in red, and I'm just going to try to get to a place of understanding, and I'm going to treat the red as variables themselves. So I have a variable squared plus 3 times a variable plus 2. And really, I am going to say this is the product. This follows a quadratic pattern. Agreed? We have a squared, we have a constant, and we have a 1 degree polynomial in the middle, or 1 degree term in the middle. So I know I'm going to use the product sum rule. There we are. What two numbers multiply to 2 but add to 3? Positive 1, positive 2. And this is equal to 0. The next thing I'm going to do is I'm going to use the zero product property and equate both factors to 0. Then I'm going to solve both of these factors. So I can say tan theta is equal to negative 1. And tan theta, if I subtract negative 1 to both sides, and over here I'm going to subtract negative 2 to both sides, Tan theta is equal to -2. So really, my solutions are tan theta are equal to -2 and -1. But in real life, air quotes around real life, I get that I'm teaching trigonometry. We are always trying to solve for theta. Rarely are we trying to solve for the tangent ratio, but this is going to help us when we hit that roadblock. Last but not least, let's have some fun. I'm going to put tan in blue. That almost made it really bad. Actually, barely see. And my sine is another variable. It's in green. Now, the variable is actually sine theta. But so what do I have? I have to use the zero product property, right? It's almost two variables. So tan theta, we cannot collect like terms, times sine theta. I'm going to subtract 3 tan theta from the left-hand side. The next thing I can do is I look and I notice that in this binomial, we have a common factor of tan in each term. So I can factor out tan theta. So tan theta, and if I factor out tan theta from this, I end up with sine theta. And if I factor out tan theta from the second term, I end with -3. Now remember, when I say factoring it out, it's very similar to dividing. So this is nowhere near right, but it definitely is similar. Tan sine theta divided by tan just leaves me sine theta. -3 tan theta divided by tan theta leaves me with -3. So that's how you get it. You can double check by multiplying this out. And you should end up with the above. Now I use the zero product property for both factors. We know that tan theta is equal to 0. And we also know that sine theta -3 is equal to 0. So I already have this solved for tan theta. Tan theta can be equal to 0. Or solving for sine theta can be equal to +3. Exactly what we have. Now this might take some practice. So definitely, please work on this. Have questions, please ask.